Hello, my dear students. Good evening. Today we are discussing the some important questions from the chapter electricity. Already we have completed the first session on this chapter. We have discussed some important questions on this chapter. Today we are continuing this session. Okay. Yes. So in this chapter we are going to solve the some important questions so that are asked in the different year question papers, as well as some important questions from this chapter. Okay. Yes. So let us start with the first question. I hope all are ready to listen the class. Please note down the questions and please try to solve the questions while after reading the sums. So mainly we are solving the important problems from this chapter, so please try to practice and please try to solve the questions. Okay. Yes. I hope my voice is audible for you people. Yes, I will start with the first question, that is, draw the diagram of an electric circuit in which resistors R1, R2 and R3 are connected in parallel, including an ammeter and voltmeter, and mark the direction of the current. Here, you should draw the circuit diagram. It should contain the three resistors and they should connect in parallel. So, parallel connection means three. Just I will draw the rough diagram. Okay. Yes. So, these are the three resistors, and voltmeter should be connected in parallel to this. This is the voltmeter, and ammeter should be connected in series, and it should contain the battery. So like this, should draw the diagram. This is the rough diagram. I will show the actual diagram how to draw this. Okay. So these should be here. Here, yes, these are three resistors, R1, R2 and R3, three resistors, and here voltmeter which is connected parallel. Okay, which measures the potential difference. Then here there is ammeter, and this is the plug key, and this is the battery. So these all should be in this, uh, and what you have to mention, the direction of the current. You should mark the arrow mark. Direction of the current also you should mark. Okay. So this is how to draw the when three resistors are in parallel and with voltmeter, ammeter, plug key and the battery. Okay. Yes, and you should mention the direction of the current also. Yes, I hope uh, you got this point, and I will move to the next question. Is it advantageous to connect the electric devices in parallel instead of connecting them in series? Why? Why we should connect them in a uh, uh, parallel, not instead of the series? So that is the question. And second question is, according to Joule's law of heating, mention the factors on which heat produced in a resistor depends. According to this law, write the formula used to calculate the heat produced. Okay. Yes. The let us start with the first question, that is, a parallel circuit divides the current through the electric gadgets. So there is a current which divides. The total resistance in a parallel circuit is decreased. This is helpful particularly when each gadget has a different resistance and requires a different current to operate properly. So in case of the series connection, the same amount of the current is transferred to the all gadgets. So if there is a if any device damage, so there is a chance of whole circuit breakdown. If one electrical device damage, it will not affect the other devices. This is in case of the parallel connection of the devices. Hence, the other devices continue to work properly. The voltage across each electrical device is same, and the device can take current as per its resistance. The voltage across each electrical device is same. The potential difference voltage is same, but the current which is divided and it is the same, and the device can take the current as per its resistance. So each devices they can take the current as per its resistance, but these all are not possible in case of the series connection. So the parallel connection is made in a uh, circuit than the instead of the series connection. Okay, so they will ask this is the very important question. So they will ask this question in a different manner, so that different questions we have studied in the last class also. Next question. According to Joule's law of heating, mention the factors on which heat produced in a resistor depends. And according to this law, write the formula used to calculate the heat produced. So, which formula is used to calculate the heat produced? So, let us the first question. According to Joule's law of heating, the heat produced in a resistor depends on three factors, that is current, the square of the electric current flowing through the resistors, and resistance, the resistance of the resistors, and time, the time for which current flows through the resistor. So these all things so the Joule's law depend on these three factors. And what is the formula which is used to calculate the heat produced? That is H is equal to I square RT. So this formula is used to calculate the heat produced. Okay. Next question. Yes, read the question properly. An electric refrigerated rated 400 watt is used for 8 hours a day. An electric iron box rated 750 watt is used for 2 hours a day. Calculate the cost of using these appliances for 30 days if the cost of 1 kilowatt hour is rupees 3. Okay, let us write down the given data here. The power of the electric refrigerator, that is equal to 400 watt, and how many hours it is used, time, so that is equal to 8 hours. How many days? So that is used up to 30 days. Okay, and iron box that is having the power 750 watt and use 2 hour, time that is equal to 2 hours, and approximately total 30 days it is used. Okay, so and cost of 1 kilowatt hour, so that is equal to 3 rupees. So these all are the given data you should mention. Okay, okay, I will clear this. Now I will calculate the energy used by the refrigerated in a 30 days. So the energy, I will take the new page. Energy consumed by refrigerator in 30 days, refrigerator, that what you have to write, what is the power of the refrigerator, that is 400 watt, 400 watt, 400 watt, how many hours? 8 hours in a day. How many days? Total 30 days it is used, right? So you have to multiply this. Yes, calculate the answer. 400 into 8 into 30, that is equal to 96,000 watt hour, right? So and energy, next one, energy consumed by iron box iron box in 30 days, that is equal to here how many, what is the power, that is 750 power watt power and 2 hours per day. 750 watt into how many hours, that is 2 hours per day. How many days? Total 30 days. What is the total? Just multiply this 750 into 2 into 30. That is equal to 45,000, right? 45,000 watt hour. So total. So you have to calculate total by adding these two. So 96,000. So this I will give it as a 1 and 2. By adding these two, just you have to add 96,000 plus 45,000. So what is the total? That is plus 96,000. So that is 1 lakh 41,000 watt hour. Okay, this is 1,41,000 watt hour. So now, so this is in watt hour. You have to convert it into a kilowatt hour. So you have to divide it by 1000. So just I will directly divide it by 1000 to convert into a kilowatt hour. So I will cancel these three zeros. Yes, now that is equal to 141 kilowatt hour. So already we know that 1 kilowatt hour is equal to, I will write this, 1 kilowatt hour is equal to 3 rupees, right? 3 rupees. So what is the value, what is the cost of 141 kilowatt? That is 141 into 3, that is equal to 3, 12, 3 4s are 12, 423 rupees. Yes. So what is the cost? So the final answer should be, that is 423 rupees for this. Okay. Yes. So like this, you should do this sum. So different types of the sums asked on this type of question. Okay. Yes. I hope you got this question, and I will solve the next question now. Yes. What is the SI unit of potential difference? Name the device used to measure the potential difference. Here, what is the SI unit of the potential difference? That is volt. SI unit of the potential difference is volt, and name the device used to measure the potential difference. That is voltmeter. Here, voltmeter. Voltmeter is used to measure the potential difference. Next question. Observe the diagram. Given circuit. Here, calculate the total resistance in the circuit and the total current flow in the circuit. Okay, you have to calculate total resistance and total current flow in this circuit. So let us write the R1. R1 is equal to R2 is equal to R3 is equal to, and what is the value of potential difference? Here, what is the value of R1, R2 and R3? Here, R1 2 ohm and R4 is also there. Here, R1 I will take it as a 2 ohm already given. R2, that is 4 ohm, and R3 is also 4 ohm, and I will take another series connection as a R5, that is equal to 5 ohm. Okay. And V is equal to 6 volt. So these three are connected in series. These three 2 ohm, 4 ohm and 4 ohm resistors are connected in series, and this 5 ohm resistor is connected, sorry, these are connected in parallel and 5 ohm resistor connected in series. So you have, first you have to find out the total resistance. Okay, let us find out the total resistance. V is equal to, that is 6 ohm, sorry, 6 volt. Now let us find out the total resistance in a parallel connection. What is the formula? 1 by Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here 1 by 2 plus 1 by 4 plus 1 by 4. So I will take 4, 2 plus 1 plus 1. So that is equal to 2 plus 4 by 4, that is equal to 1 ohm. Rp is equal to, here I will write Rp, total resistance in a parallel connection, Rp is equal to 1 ohm, right? So, and one more resistor that is connected in series. So, you have to find out the total resistance. When connected in series, Rs is equal to R1 plus R2 plus R3, like this it is. So, here total resistance R1, I will take it as 5 ohm, 5, and R2 I will take it as a total resistance of the parallel resistor. So that is equal to 6 ohm. So total resistance, then total R is equal to, I will take, that is 6 ohm, because first we have to find out the resistance of the parallel resistors, that is 1 ohm, then one more resistor that is connected in series, so we have to apply the formula. So when we add this, so we will get the total resistance 6 ohm. So what is the question? You have to find out the total resistance of these resistors, that is 6 ohm, and here you have to find out the uh, current flow through this resistor. So I is equal to V by R. So what is the value of V? So that is 6, and what is the value of R? So that is also 6. So that I is equal to how many ampere? 1 ampere. So this is the total current flow, and this is the total resistance. R is equal to 6 ohm and I is equal to 1 ohm is the correct answer. Yes, please note down this. Yes, now I will clear this. So next question. A battery of 9 volt is connected in series with resistors 0.2 ohm, 0.3 ohm, 0.4 ohm, zero point 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistors? Here, when the resistors are connected in series, so you have to apply the formula Rs is equal to R1 plus R2 plus R3. So this formula you have to apply, plus here total resistance first you have to find out to find the current. R1 I will take it as a 0.2 ohm, and R2 that is 0.3 ohm plus R3 that is 0.4 ohm plus R4 that is 0.5 ohm and R5 that is 12 ohm. Okay. R4 plus R5. Okay. Total 5 resistors are there. So that is the 12 ohm. So total resistance 0.5, 0.9, 1.4, 13.4 ohm. I hope this is the correct 13.4 4 or 5? Yes, calculate this. 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. That is equal to 13.4. Yes, 13.4 ohm. The total resistance is 13.4 ohm. So here they asked how much current would flow through the resistor, 12 ohm resistor. If it is in case of the parallel connection, you can take the 12 ohm resistors directly, but here in case of the series connection, the current flow these from these resistors, so that is same in all the resistors. So you have to take I is equal to V by R formula. Here V already given, V is equal to 9 ohm, 9 volt. So here V is equal to 9 divided by R. R is total resistance, that is 13.4 ohm. So then I is equal to 9 divided by 13.4, that is 9 divided by 13.4, that is equal to, what is the answer? 9 divided by 13.4. So that is 0.671 ampere. So this is the answer. Okay, please note down the answer. Yes, you can solve the question like this also. Uh, so total resistance 13.4 ohm and I is equal to V by R. So that is 0.671 ampere to the 12 volt battery. Okay, so this is the correct answer. Next question. When a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. So here V is given, that is V is equal to 12 volt. Then current I is equal to 2.5 milliampere, not it is given in a ampere, it is given in a milliampere. So here R you have to find out what is the value of R. You know the formula V is equal to IR, then R is equal to V by I. Already you know the value of V, that is 12, alva 12, then here I is 2.5 milliampere. I will write it as a 2.5 into 1000. 10 raised to minus 3 also you can write. I will write 1000. Okay. Then I'll this 1000 that will move in upside. 12 into 1000 divided by 2.5. Can you solve this? 12 into 1000. 12,000 divided by 2.5. Yes. That is equal to 4800 ohm, but I have to convert into I will write 4.8 kilo ohm. Okay, 4.8 kilo ohm. So this is the answer for the correct answer for this question. Okay. Next question. How many 176 ohm resistors in parallel, okay, in parallel they have to connect, are required to carry a 5 ampere on a 220 volt line? So you have to find out how many resistors are 176 ohm resistor should be connected. Here, please write down the given data here. Resistance that is 176 ohm, and current I is equal to 5 ampere, and what is the old voltage, that is 220 voltage. So these all given data you should write. So now apply the formula, that is 1 by Rp. 1 by Rp is equal to 1 by R into N. We don't know how many resistors are connected. 1 by R1, 1 by R into N, because we don't know how many resistors, 3, 4, 5, how many resistors are connected, this formula. So here Rp value, Rp is equal to, just in this, I will take it as a equation. Rp is equal to, how we can write? Rp is equal to R by N. I hope you got this. This is, I will take it as a equation 1. Okay. So if you solve this, you will get the answer Rp is equal to R by N. Okay. Then you know the formula V is equal to IR. You know the formula V is equal to IR. Then I will apply V is equal to 220 volt. Then I already given, that is 5. And what is the value of R? Here R means Rp, total resistance. R is equal to R by N I will take. Okay. So here again 220 volt, 5 into, what is the value of R? R is given, that is 176 ohm. 176 divided by N. Can you find out the N now? N is equal to, what is the value of N now? I will take here. N is equal to, how you can write? 5 into 176 divided by, so N. So sorry. 5 into 176 divided by 220. Yes, this is correct. Divided by 220. 5 ones are, 5 fours are 20, and 2 5 fours are 20. 2 twos are 8s are 8s are 1 1, sorry, 2s are 8s are 2 ones are 2 fours are. So N is equal to 4. So how many resistors, they had asked the question, how many resistors should be connected in parallel to make this possible? So that is, how many 176 ohm resistors are required to carry 5 ohm on a 220 volt line. Okay. So total N is equal to 4. How many resistors? That is 4 resistors. Next question. A hot plate of electric oven connected to a 220 volt line has two resistant coils A and B, each of 24 ohm resistance, which may be used separately, in series, or in parallel. What are the currents in the three cases? Here I will take R1. R1 is equal to 24 ohm. R2 is equal to, that is also 24 ohm. So they are having A and, or I will take RA and RB. Okay, 24 ohm. So V is equal to 220 volt, right? Here, which may be used separately, in series, or in parallel. What are the currents in three cases? When it is used separately, when it is used in a parallel, when it is used in a series. Here 1 by, I will apply parallel connection. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 formula. Here 1 by Rp is equal to 1 by 24 plus 1 by 24, right? Sorry. Uh, yes. So 1 by 24 plus 1 by 24 here. 24 divided by 2. 2 ones are 2, 12. Rp is equal to, that is equal to 12 ohm. So you have to find out current flowing through this when it is in parallel. I is equal to V by R. Here V is equal to, that is 220 volt. R is 12. So I is equal to 12 ones are 12 ones are 12. That is 220 divided by, just do it, 220 divided by 220 divided by 12. That is equal to 18.3 ampere current. So when it is connected in a parallel, what is the current flow? That is 18.3 ohm. When it is connected in a series, that is R1 plus R2 plus R3, so that RS is equal to formula you have to apply. That is R1 is 24 plus 24, that is equal to 48 ohm. What is the resistance? That is 48 ohm. Here total current you have to find out. I is equal to V by R formula. Here V is equal to 220 volt divided by 48. Can you solve this? 2 2s are 2 4s are 2 1s are 2 1s are 0. Then 2 1s are 2 2s are 2 5s are 10. 2 5s are 10. 12 divided by 55 means 4.58 something ampere. So this is the current flow when it is connected in series. When it is connected in separately, I will do it here separately. When it is connected separately, so total resistance is R is equal to 24 ohm. So I is equal to V by R formula. So V 220 volt divided by 24, that is equal to 9.16 ampere. So three cases you have to solve. First, when they are connected in parallel, what is the total resistance? That is 12 ohm. And when what is the current flow? That is 18.3 ampere. Okay. When it is connected in series, so what is the total resistance? That is 48 ohm. And what is the current? That is 4.58 ampere. When it is connected separately, R is equal to 24 ohm total resistance and I is equal to 9.16 ohm. So these three cases you have to solve. Okay. So I hope you got this. Yes. Next question. Show how you would connect three resistors, each of resistance 6 ohm, so that combination has the resistance of first one 9 ohm and the 4 ohm. So what you have to do, three resistors you have to take, that is having the R1 is equal to 6 ohm, R2 that is equal to 6 ohm, and R3 that is equal to 6 ohm. So what you have to do here, each resistors, so when you should make a combination of these resistors that should have the total resistance 9 ohm and the 4 ohm. Okay. So first I will apply the series rule. When these three resistors are connected in series, R1 plus R2 plus R3, when this connected in series, that is 6 ohm plus 6 ohm plus 6 ohm, that is 18 ohm. Total resistance will be 18 ohm. So which is not correct. It should be 9 ohm. Okay. So if you make these three resistors in series, so which is not possible, then I will take these three as a series connection. So all are connected in series. So that is, what is the formula? 1 by R1, Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 formula. So here 1 by 6 plus 1 by 6 plus 1 by 6. So here 6 divided by 3, 3 ones are 3 twos are, Rp is equal to 2 ohm. So the total resistance of when they are all three are connected in parallel, they will be, that will be 2 ohm, which is also not correct. So we have to make, then what we have to make? We have to make both combination, both series and parallel connection. Now I will take, so just see the connections. Two resistors should be in parallel. So parallel connection of these resistors. Okay. And meter is here. One more resistors in series. Okay. So like this, if 6 ohm, 6 ohm, and this is 6 ohm. So now I will take the 1 by Rp is equal to 1 by 6 plus 1 by 6. Please write the formula, and 6 divided by 2. So Rp is equal to 3 ohm. Okay. Now this is connected in series. So series formula, that is Rs is equal to R1 plus R2 plus R3. So R1 plus R2 I will take here. So total resistance of these resistors, that is 3 ohm, plus it is connected in series another, that is 6 ohm, that is equal to total resistance will be 9 ohm. So the first condition is solved. When two resistors should be connected, when two resistors are connected in series and parallel, and one resistor is connected in series, so the 9 ohm combination is possible. Two resistors in parallel and one in series. So this combination should be done for 9 ohm total resistance. Okay. Let us solve the next condition, that is 4 ohm resistance. Okay. So here 4 ohm resistance. First, I will connect the two in series, that is, and one in parallel. Okay. One resistors in parallel. So like this, I will do the connection. So first you have to do the series connection. Series connection. Two resistors are connected in series. Rs is equal to 6 plus 6, that is equal to 12 ohm. And this 12 ohm, so that is connected in parallel to the next resistor. So I will apply 1 by Rp is equal to 1 by Rp is equal to 1 by 12 plus 1 by 6. Okay. So here 12 divided by 1 plus 2, that is 3 divided by 12. 3 ones are 3 fours are. So Rp is equal to 4 ohm. So second condition also done. So what is the connection you have to do to get the 4 ohm? Two resistors in series and one resistor in parallel. So this is how to solve this question. Just see this. Yes. So this is how when two resistors are connected in parallel and one is connected in series, and this is where the two resistors are connected in series and one in parallel. Okay, so you will get the answer. Yes. Next question. Compare the power used in 2 ohm resistors in each of the following circuits. 6-volt battery in series with the 1 ohm and 2 ohm resistors, and 4-volt battery in parallel with the 12 ohm and 2 ohm resistors. You have to compare the power used. P you have to find out. Here in the first battery, what is the power used? V is equal to 6 volt, R1 is equal to 1 ohm, and R2 is equal to 2 ohm. Here total resistance R is equal to 3 ohm, right? Then power is equal to P is equal to V into I formula also you can apply. Here find out the I. I is equal to V by R, that is V is 6 and R is 3. 3 ones are 3 twos are, that is 2 ampere. Total resist V is 6 and total resistance that is 3 ohm, 2 ampere. I is equal to 2 ampere. I is equal to 2 ampere and R total resistance R is equal to 3 ampere. And what is the P is equal to V into I formula? V is 6, I is 2, that is 12 watt. So what is the power used in a first condition? That is 12 watt. Okay. Then find out the 4-volt battery in parallel with the 12 ohm and the 2 ohm resistors. So here also I will apply the same formula, that is already when they are connected in parallel. Okay. So when they are connected in parallel. Here 1 by 12 plus 1 by 2, 1 by Rp is equal to 1 by Rp is equal to, so here 12 divided by 1 plus 6, that is equal to 12 by 7. I will ohm, 12 by 7 ohm. Okay. So total resistance is equal to 12 by 7 ohm. Here find out the I. I is equal to V by R. Here V is 4 volt and 12 by 7. So 7 will add here 28 by 12, that is I is equal to 2.30 ampere. Okay, just I will solving. So now P is equal to V into I. Um, V is equal to 4 volt and I is equal to 2.3. I will take just for the reference. So what is the value? 4 into 2.3, that is equal to 9 point something. 9.12 watt. Okay. So this is the one method of doing this sum, and one more method is there. So here you can apply the another formula, that is P is equal to V square R. V square by R. Here ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಯಾವ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿದರೆ power, that is 1 ohm and 2 ohm resistors when they are connected in series. So you know the total resistance, that is 3 ohm. Then apply the V square by R formula, that is 36 divided by 3, 12 watt. So if you apply P is equal to V into I formula also, that will be same. Then for the calculation, total resistance will be 12 by 7. Already we know this. And here they are not applying the P is equal to V into I. They are not calculating the I. They are directly applying the P is equal to V square by R formula. That is also power. V square, that is the 16 divided by 12 by 7, that is 9.33 watt. That is also same. In two methods we got the same answer. Okay, but this will be easy because there is no calculation of the I calculation ಮಾಡಬೇಕು ಅಂತ ಇಲ್ಲ, ಇಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ನೀವು V square by R P is equal to V square by R formula apply ಮಾಡಬಹುದು. So this method will be easy for you people. Okay, this next question. Two lamps, one rated 100 watt at 220 volt and other 60 watt at 220 volt are connected in parallel to electric main supply, and the current drawn from the line if the supply of voltage is 220 volt. Here I will take V1 is equal to 220 volt and V2 also, that is 220 volt. So I will take the new page. V1 is equal to, that is 220 volt. Then P1, what is the power drawn? That is equal to 60 watt, right? So 60 watt, check it once. That is 220 volt. One rated 100 watt and sorry, yes. So this is 100 watt. 100 watt. Okay. And V2, what is the V2 value? That is 220 volt and power drawn, that is equal to how many watt? And 60 watt. So that is 60 watt. Okay. Here, what is the current flow? You have to find out, right? What is the current flow? What is the current flow drawn from the each line of voltage 220 volt? So write the formula P is equal to V into I. Okay. Here I is equal to, I will convert into P by V. So you know the value of P in case of the first one, that is 100 divided by 220. Okay. So that is I is equal to, I will write it as a 10 by 22 ampere. Okay, only like this I will write 10 by 22 ampere. In case of the another one, P is equal to V into I formula. Again change it as a I is equal to, you have to find out I is equal to P by V. What is the value of P? That is 60 divided by 220. Okay, here I is equal to 60 divided by 22. Then what you have to find out? You have to find out the total current. So that is I1 plus I2. So I will take it as I1 and this is as I2. I1 plus I2. So total I is equal to I1 plus I2. So I1, that is 10 by 22 plus I2, that is 6 by 22. 22 divided by 10 plus 6, that is 16 by 22. So 16 by 22 means 16 divided by 22 means that is 0.72 ampere. 0.72 ampere. Okay, I will write it once again here. you have to find out the current, right? Here, this is the I1 and I2. I is equal to I1 plus I2. Here, I is equal to I1 is 10 by 22. I2 is 6 by 22. So, I will write 22 divided by 10 plus 6. That is equal to 16 divided by 22. What is the answer? That is 0.72 ampere. Okay. So I is equal to 0.72 ampere. So this is the correct method of solving this question. Okay. Yes. You can solve this question like this also. Yes. This is how to solve this question. Another method. Yes. Next question. Which uses more energy, a 250-watt TV set in 1 hour and 1200-watt toaster in 10 minutes? Here, I will convert first the energy used by the 250-watt or more energy set in 1 hour and 250-watt toaster. 1 hour, I will convert it into seconds. So 1 hour means how many seconds? 60 minutes. 60. Okay. 60 minutes. 60 minutes means how many? 1 hour means 60 minutes. 60 minutes means how many seconds for minutes? That is 60 seconds. So total 3600 seconds, right? So that you have to convert. So I will write 250 into 3600. 3600, that is equal to 250 into 3600. Just a minute. 250 into 3600. That is 9 lakh, right? 9 into 10 raised to 5. I will write it as a 9 into 10 raised to 5 watt. Okay. Then energy consumed when 1200 1200-watt toaster in 10 minutes. 10 minutes means 60 seconds. So total how many seconds? 600 seconds. So that is equal to 7.2 into 10 raised to 5. Okay. So here which uses the more energy? So energy used, that is this 9 into 10 raised to 5, that which uses the more energy, that is toaster, which is having the 250-watt power and which is at 1 hour. So that is used more energy. Okay. So that is the correct answer. Next question. An electric heater of resistance 8 ohm draws a 15 ampere from the service mains 2 hours. Calculate the rate at which heat developed in the heater. Here, what formula you have to use? R is equal to 8 ohm and I is equal to 15 ampere and time is equal to 2 hours. It is given. And which formula you have to apply? So H heat produced, that is H is equal to I square RT formula I will apply here. Here H is equal to I square, that is 15 into 15 R 8 ohm, and so 1 hour means 2 hour means, that is in seconds, that is 7200 seconds. So a total, how we can write it? 1800 into 7200 200. So that you can multiply. Okay, 1800 into 7200, that is equal to, so that you can convert. Then rate of H is equal to, will take it as a H is equal to 1800 into 7200. So that value. So rate at which, that is P is equal to H by T formula I will apply. H is equal to 1200 divided, sorry, 7200 into 1800 T. What is the value of T? That is 7200. I will cancel this. So what is the rate at which the heat is developed in the heater? That is 1800 watt. Okay. So that is the correct answer, 1800 watt. So students, like this we have solved some questions which are related to the electricity chapter. So this is the second session, so where I will end this chapter, the discussion of this chapter. So in the next class I will start the new chapter. Okay, thank you.